Okay, so now we would like to talk about the Maya fluids container details. We first would like to begin with the density. So what exactly is the density of the fluid? Well, to be straightforward and in a very simplest way, I would like to describe that the mass per unit volume is described as the density, which is a very standard definition you may could get. And think of the fact that we have a empty container or we have an empty spherical object and we want to fill it with liquid or you may could say some gas. So the area occupied by that liquid or the gas will be called as the density of the fluid. Let's just begin with some few more definitions like the material property of a substance or fluid in the real world. And density represents the surface of the fluid it appears and the overall visibility with respect to its opacity. It represents the volume the fluid has occupied. All right. So I hope the meaning density is clear to all of you. And one important thing is that we have the density scale inside the fluid. So once we take this discussion inside the practical Maya, then you'll get the chance to see all these attributes will going to appear inside the Maya. So it will be very important for you to figure out that what exactly we are learning in this clips, and if you're very careful regarding the terms, the definitions, you would really going to enjoy the learning inside the practical lessons, or you may could say when we take this discussion inside the Autodesk Maya software, where I would be covering each and everything what I am discussing in this module. All right. So let's go ahead with the elements of our, or you may could say the attributes of our density, which is the density scale and the density pressure. So the density scale is the universal. This attribute is the multiplier for all the attributes that are underneath it. And the density scale here describes the density of the fluid container, and we never would like to take this value to the 1 because objects like the gold, wood also, they do emit the light to get pass away from them. So the density scale is important parameter and we'll never like to give it the value to the 1. You may could leave that thing to the 0.5, 0.75 or 0.65, stuff like that. And the next one is the density pressure. So the density pressure is an outward force which Maya fluid applies and it will try to expand the fluid. It's really very important parameter and we're going to utilize this one when we will going to create the effect of the thick smoke while working upon the density sections of the fluids. And the next we have is the buoyancy and the gradient force. So the buoyancy is the property of the fluid. With the positive values, they tend to remain upward on the surface of the fluids or a substance, and the negative value will tend to fall down. So the example for the positive value would be the wispy smoke or the hot smoke, and for the negative values we have the dry ice, which always try to fall down. The gradient force is a force which is, it kept increasing with the increase in the density inside the voxels. So this force will going to apply the not exactly the pressure, but a kind of a force towards the XYZ axis inside the container of the fluids. And then we have the dissipation and the density tension. So the dissipation is the naturalistic behavior of the fluid when it tends to get dissipate or get vanished. Think of the fact that you have the smoke and it cannot flow forever in the air or in the atmosphere. The moment it rises more high, it will try to get dissolved inside the atmospheres. The density tension is a property somewhat we could relate it to the surface tension inside the water, we could say, which try to preserve or reserve the volume into tiny droplets kind of thing. But in case of the gaseous phenomena, it will also try to give us some round kind of the shapes of, or you may could say, clouds or smoke puff. Moving ahead, we have the diffusion and the density tension force. So first we'd like to discuss with the diffusion, which is the property of spreading out of the fluids in the neighboring boxes. You cannot mix that thing with the dissipations. Alright, so diffusion is somewhat like that. There's a ball of the fluid, and if you increase the diffusion, it'll start getting spread inside the container. Okay, we really use this attribute, is very useful once you're simulating the candle flame kind of a thing, so where you need some sharpness in like the fluid from the top side areas. So the next thing would be the density tension force. Again, this is a property related to the density tension. Try to make some stretchiness inside the fluids, and it's very useful in case of the wispy smoke. The last one would going to be the noise, which is you could figure that out, the kind of the disturbances or the randomness inside the voxel values of the density. So it will try to get some bumpiness, or you may could say some surface relief inside the smooth flow of the fluids. So with that, we are done with the section of the density, and hope you well understood the concept of the density. I again would like to repeat, it's the material property of a substance, and you may could imagine the fact that we have the sphere and we like to fill some elements inside the sphere. So the area or the density, you may could say the section occupied inside that space will going to be defined as the density. All right. So we are done with this clip, so I'm taking a pause over here and would like to begin with the new clip where I would be discussing the concepts of velocity and the turbulence.